All right, let's jump right in. We're swimming in data every single day, right? Statistics, studies, they're all telling us what to believe, what to buy, you name it. But here's a thought. What if the very way we measure and understand the world is, well, broken? Today, we're going to break down two huge types of bias, the ones hidden in the data itself, and, maybe more importantly, the ones hardwired right into our own brains.
I mean, it seems like a simple question, but the answer? Whoa, it gets complicated fast. Think about it. You see a big, flashy headline. 90% of users prefer this new gadget. Do you ever, stop and think, wait a minute, who were these users, and how exactly did they ask them that question?
See, that's the thing. Behind every single number, every graph, every stat, there's a person. And that, right there, is where it all gets messy. Because we're not just talking about bad math here. We're talking about the tricky, sometimes weird ways our own minds work.
So let's start with the first piece of the puzzle, statistical bias. And I love this analogy for it. Imagine you're trying to measure a room, but your ruler is crooked. It doesn't matter how careful you are, right? Every single measurement you take is going to be off from the get-go.
And the magic word here is systematic. This isn't some random mistake like a typo. No, this is a flaw that's built right into the system, the way the data was gathered or crunched. And it's constantly, consistently pushing the results in one specific direction.
Okay, here's a super simple example. Let's say a drug company is testing a new cold medicine, but they only test it on men. Can they then turn around and say it works for everybody? Of course not. Their ruler, that sample group, was totally crooked. It didn't look anything like the actual population.
And believe me, there are a ton of ways for that ruler to be crooked. You've got selection bias, which is what we just talked about, picking the wrong group of people. Then there's funding bias, where the people paying for the study might nudge the results to look good for them. Or attrition bias, where people drop out of the study and you're left with an incomplete picture. And a really common one is recall bias, which is just that people are terrible at remembering stuff accurately. Like asking someone how many cigarettes they really smoked last week, yeah, good luck with that. Each one of these is a different kind of crooked, and they all mess up the final result.
Okay, so that's the crooked ruler, basically flawed data. But what if the ruler is perfectly fine, totally straight, but the person reading the ruler is wearing, say, rose-tinted glasses? Well, that brings us to a whole other universe of problems. Cognitive bias. These are the flaws, the shortcuts built right into our own thinking.
Now, let's be clear. These biases don't mean you're not smart. Actually, it's kind of the opposite. Our brains developed these little shortcuts, the fancy term is heuristics, to help us make snap decisions and, survive. The problem is, in today's world, which is just overflowing with complex data, those same life-saving shortcuts can seriously backfire.
Oh yeah, this is the big one, confirmation bias. I mean, just think about how you use the internet. If you're convinced cats are superior pets and you Google why cats are better than dogs, you're going to find a mountain of evidence. But if you search why dogs are better than cats, you'll find a completely different mountain of evidence. You're looking for proof for what you already think is true. And trust me, the internet will always deliver.
Then you've got something called anchoring bias. This is where you get stuck on the very first piece of information you hear. Ever seen a price tag that says $500 crossed out and replaced with $100? That first number, the $500, becomes an anchor. It makes the $100 seem like an amazing deal, even if the item was never worth $500 to begin with. It just sticks in your head.
And what about the availability heuristic? This one's all about what's easy to remember. So if your company just had a huge security scare last week, you're probably going to be way more worried about another one happening tomorrow. The memory is fresh, it's right there at the front of your mind. So you overestimate the actual risk, even though the real-world odds haven't changed at all.
So just to recap, we've got the crooked rulers, which is just bad data, and we've got our brain shortcuts, which can lead to bad thinking. Now, each one of these is a problem on its own, for sure. But what happens when they smash into each other? Oh boy, that's when you get a perfect storm for creating myths and misinformation that can spread like wildfire.
And this is where it all comes together. We have flawed data, and we have flawed brains. But what happens when our flawed brains are the ones creating the data in the first place? What happens when a scientist, who's supposed to be completely objective, gets tripped up by their own mental shortcuts while doing their work?
Well, that's exactly what modern research is digging into. This quote from a paper just this year really hits the nail on the head.
It basically says that a lot of the problems we see in research aren't because scientists are careless or trying to cheat. Nope. It's because of these cognitive biases, the same ones we all have, and they end up causing some really big problems.
You can actually see it as a chain reaction. Let's walk through it. Step 1. A researcher has a hunch, an idea they really believe in. That's their confirmation bias kicking in. Step 2. They go looking for proof. Maybe they p-hack. That's a term for twisting and turning the data in a bunch of different ways until, voila, a statistically significant result pops out. It's like cherry picking. Step 3, this flawed study gets published and enters the official scientific record. And then, step 4, the myth starts to grow. Other scientists see the study, they cite it in their own work, and thanks to something called the repetition effect, the more this bogus finding gets repeated, the more it starts to sound like a fact. And suddenly, you have an entire myth that's been baked into the scientific literature. Now, this whole chain reaction, it's been a problem in science for a long, long time. But now, we've thrown a massive supercharger on it. A new technology that can amplify these old human problems on a scale that is honestly mind-boggling. And that technology, of course, is AI. Think about it. How do AI models learn? They're trained on absolutely gigantic piles of text and data from the internet, all written by us, by humans. So if our scientific papers, our articles, our books are filled with these biases and repeated myths, what do you think the AI learns? It learns our biases, our myths, our mistakes. And here's the scary part. One flawed scientific paper might be read by a few dozen people. An AI can confidently state that same flawed idea to millions of people in a single day. The scale is just wow. And this isn't theoretical. Here's a real-world example. There was this old statistical rule that was, frankly, just wrong, but it had been repeated in academic papers for decades, over and over again. So researchers went and asked an AI about it. And what did the AI do? It repeated the myth with total confidence as if it were a solid fact. Why? Because it had read all those papers, and thanks to that repetition effect, it learned the myth was the truth.
Okay, so this all sounds a little bleak, right? If our data can be crooked and our brains are full of these shortcuts, what are we supposed to do? Well, the good news is, while we can't exactly rewire our brains, we can get a lot smarter about spotting these traps and becoming more critical consumers of information.
All right, let's put together your personal debiasing toolkit. First thing to always ask, question the sample. Who was in the study? Who was left out? Are we dealing with a crooked ruler here? Second, and this is a tough one, actively fight your own brain. Go look for evidence that proves you wrong. Third, always check the sample size. A 90% success rate sounds great, but it means something very different if it's from 10 people versus 10,000 people. Look for cherry picking. Are they only showing you the good news? And maybe the most important tool of all, just be aware. Know that your brain has these shortcuts. Recognizing them is honestly half the battle.
Look, at the end of the day, bias isn't a bug in the human system. It's a feature. It's just part of how we're wired. So the challenge isn't to get rid of it completely, because we can't. The real challenge is to be smart enough to see it and account for it. To see it in the data we consume and to see it in ourselves. The goal here isn't to be perfect. It's just to be more aware. So I'll leave you with this. The next time a statistic or a study flashes across your screen, how are you going to question it?